According to the Alzheimer's Society, in 2015, 850,000 people in the UK will have some form of dementia, with the figure predicted to rise to 1 million by 2025. It's an often undiagnosed disease, which is most common in older people, but it can occur as early onset in middle age. For people with learning disabilities, the condition can occur even earlier.
Dementia appears to be more frequent now partly because we're much better at looking after old people. People don't die young so often now. If you live to 40, 200 years ago, you were an old person. If you live to 75 or 80 now, this is the normal life expectancy.
Alzheimer's disease, which is the commonest cause of dementia, doubles in prevalence with every 5 years we live over the age of 60. So that people in their 80s and above, 1 in 5 have dementia. Essentially it means that the things that make us higher thinking beings, our memory, our way of calculating, of planning, language, they are degenerating.
Dementia is anything which is affecting the brain and the loss of function of the brain in such a way that the things that we normally take for granted, for example, our ability to remember things, times, dates, events, to place ourselves in a location, to use words, to use language, all of these things begin to disappear.
The most common early signs of dementia include memory problems, decline in communication skills, recognition and coordination difficulties, disorientation, as well as changes in behaviour, judgment and mood, and loss of daily life skills. Dementia results from a loss of brain function. As we get older, in a normal brain, there's very little change with age.
What we see is if we take somebody who's got normal aging, this is their first scan, and we take a second scan a year later, there's very little change. It's quite different in Alzheimer's disease.
Brains of people with Alzheimer's, the most common form of dementia, shrink dramatically.
There's devastation going on. Alzheimer's disease is destroying brain cells and the brain is shrinking.
Depending on where those changes are, for example, if they're in an area which is important for memory, then memory will be disturbed. If they're in an area that's important for language, then you will lose ability to understand words or to be able to use language in the way that you perhaps might have done.
These are the observable changes, but what's happening within the brain to cause them? Brain cells called neurons communicate with each other via electrical impulses which trigger the release of chemicals called neurotransmitters. These pass between the cells. Neurotransmitters pass between gaps in the neurons called synapses. In Alzheimer's, abnormal protein deposits inhibit the neurotransmitters' signals. It's common to see these protein deposits in infected brains build up into plaques and tangles. Over time, the plaques and tangles destroy neurons' ability to communicate with each other. They die off, and functions like memory and thinking skills are affected.
That process of indigestible protein, lumps of stuff in between cells, actually affects the brain function. It affects the brain cells communicating with each other, and the brain cells start to die. So, for example, this area of the hippocampus, which is so related to memory, we see shrinking down, and at the same time, at a clinical level, people complain of forgetfulness.
The hippocampus is the area of the brain most important for memory.
Now, this region here, called the hippocampus, has been long known to be important for storing and retrieving information. And we were thinking about neurons and synapses, and each of these regions is connected by a pathway where there is a neuron at one end and a synapse at the other. And if we're storing information, pathways will be activated linking the cortex to the hippocampus, and we will learn, for example, the name, somebody's name or a place or a location, and that information will be stored within the hippocampus. And when we remember something, pathways which bring it from this deep area out into the cortex, into the conscious brain, will allow us to remember something and understand the context in which we remembered it. Now, somebody with dementia, and in particular Alzheimer's disease, these pathways will be severely interrupted. And what's happening is where there will be a normal healthy pathway to store or retrieve information, elements of this pathway are lost and the cells are not working as well as they should. So therefore, when we try and store information, the ability to store it may be lost, and therefore when we come to retrieve that information, we may not have been able to store it properly, or we just not maybe able to access that information.
Alzheimer's disease has a dramatic impact upon memory. Modern imaging techniques have indicated ways to spot the disease in its very early stage.
If we look at the scan, what we see here, this is somebody with mild cognitive impairment. The scan may not look that different to somebody with a normal aging, but if we look at the change here now, just over a year, if I flick forwards and back between these two scans, that's the first scan, that's the second scan. Look at this increase, this black area is the ventricles, that space, fluid-filled space within the brain, that's enlarging. Look at the space around the hippocampus here, that's our memory store. That's just shrinking down. If we look around the temporal lobes to do with language, the frontal, the parietal lobes, thinking, calculation, spelling, they're all shrinking. If we take a series of scans of somebody in the very earliest stages of Alzheimer's disease, here's the brain scan at the beginning, here's another brain scan of the same person 18 months later, and then a further 18 months. So there's 36 months across here. That's the 3 years. That 3 years is often an insidious period of change when, remarkably, people may have some mild symptoms and they may not even get a diagnosis. Look in this blown up, magnified section here, what's happening to the hippocampus. Devastating destruction. Dementia just reflects what's happened to the person, to the brain, that syndrome of cognitive decline. Alzheimer's disease is a pathological definition.
The second most common cause of dementia is vascular dementia, a condition linked to the blood vessels in the brain rather than the brain cells themselves.
This is caused either by lots of strokes within the brain, sometimes quite small ones, or a cutting off of the blood supply to the brain in general. And this will cause various regions of the brain to die and become dysfunctional. Vascular dementia quite commonly occurs at the same time as Alzheimer's disease, so it can be difficult to say whether somebody has purely Alzheimer's disease or purely vascular dementia, but they can have sometimes a balance between the two.
These white blobs that we see here, that's destruction. That will have been a vessel having been blocked or having less blood supply to that part of the brain, and little tiny patches get eaten out. But as you progress, as the burden of this vascular damage gathers, then the thought processes slow down, the connection gets more difficult, the loss of memory, the loss of planning, the speech, the gait problems, the emotional ability, the fact that you may get more frustrated, may rapidly change in mood, they're all part of that vascular dementia.
The diagnosis of dementia is not straightforward. There are no direct diagnostic tests, and dementia affects individuals in a range of ways. A GP should be consulted in the first instance in order to assess a person and to provide help with a diagnosis. A GP is the usual person to make a referral to a specialist.
During life, Alzheimer's disease in particular is a diagnosis of exclusion. You rule out everything else, and what you have left is likely to be Alzheimer's disease.
We importantly need to exclude depression. We then will go on and we'll do imaging to exclude the rare case of a brain tumour, try and quantify how much vascular damage, is this really vascular dementia or is it Alzheimer's disease? In some situations we will do measures of brain activity. Could seizures be mimicking Alzheimer's disease or something like that?
Early diagnosis and research are being helped by MRI or magnetic resonance imaging, which gives a very detailed view of the brain.
Scanning, and MRI scans in particular, are starting to give people a little bit better certainty on the diagnosis. the real test for Alzheimer's disease is still very, very clinical. So it is actually asking somebody, taking a good history, examining them, and the imaging is just helping us to be able to make diagnosis slightly earlier. And there are novel techniques that are still in the really at the research stage, where we can actually do scans that look for the specific proteins. That's called amyloid imaging, to be able to see in life what's going on in the brain, not just in terms of the structural degeneration, but also the proteins that may be driving that destructive process.
Apart from the care that everyone living with dementia will need, drugs used in the treatment of Alzheimer's disease can temporarily improve symptoms and slow down the progression for some people. They cannot, however, provide a cure.
The real research drive is not just to try and make the brain work a bit harder or a bit better, which is what these tablets do, but more to try and find things that will halt this dreadful destructive process. And we do know that all the pathological hallmarks, amyloid plaques, the neuronal destruction, are occurring many years before anybody is ever diagnosed. So there is a window where theoretically we could intervene to preserve brain tissue and brain function at the stage when I think all of us would like it preserved.